what are you particularly excited by right now?
I think there's a whole host of things. So autonomy, I think, is going to be particularly important in the way that we look at our platforms. I don't mean autonomy in the fact that what we produce will be fully autonomous, but I think it's the use of autonomy and actually how we embed that actually with the humans actually in terms of actually our defence forces. Artificial intelligence being, if you will, on the jump to that in terms of the processing and application of information and data. If I think about materials, I think there's going to be a tremendous revolution in terms of new materials. In terms of metamaterials, different types of materials, materials that can sense, materials that actually have a degree of intelligence to them. We've already talked, you mentioned sensors, not only in terms of just embedding sensors in terms of small silicon devices, you know, they're highly connected, small, very intelligent, highly capable from a computing point of view sensors, but all the way right through to potentially quantum sensors, looking at more sensitive, potentially cheaper, smaller footprint sensors. Not forgetting, so I can go on for a long time, but one area I will pick up on, I think the other area I think is quite important. I think there's a lot of disruptive technology now actually in manufacturing. So you mentioned 3D printing, but there's this whole digital train, you know, being able to actually go from the design of something right the way through to its manufacture from a digital point of view, right the way through to its service in terms of when you've manufactured that. And I think that's a thread that's really quite important. You can see that actually in civil engineering, in terms of the way that people do that in civil engineering now. It will become important in the way that we think about our products for the future, both in terms of how we design them, make them and service them.
Great. I'll definitely come back to the manufacturing point in a moment. Janice, I will throw to you now then. What do you see as being the areas of disruption?
In addition to this, and we talk about individual technologies, and another one that gets a lot of airtime in recent times is hypersonics. But from my perspective, where digital disruption is a good example, is the combination, interfaces between the individual areas and disciplines of science in ways that you perhaps might not have imagined. So you talk about the smartphone. None of those individually was particularly disruptive. It's the combination of it. And so from my perspective, it's how we work together for data fusion, how we make use of cyber technology, how we really incorporate artificial intelligence in the broad that allows us to be disruptive and might have disruption used against us.
Right. I'll stay with you for just one moment. Who in the room understands what the term hypersonics actually means? About half of you, which means half of you don't. So maybe could I just get you to, what are we talking about? We might know supersonics. Yes. What are hypersonics?
So hypersonics is high-speed flight, maybe above Mach 4, up to Mach 8, 10, 5, you know, there's sorts of areas. So it allows...
Give you a mathematical.
Yes, that's right, yes.
I'm sure you could, Hugh.
Trying to stay away from the maths. So I think so what does it give you the prospect of? It gives you the prospect of being able to go from A to B in such short times. How do you respond to it? If you're thinking about it being used against you and how you protect against someone who might develop hypersonics and put a warhead on it, what do you do? So all the implications become very important.
You probably don't get to do very much because it's already got you before you'd realise it.
Hopefully not.
Hopefully not, so okay. Hugh, I won't ask you for your mathematical definition of hypersonics, but what do you see as being the areas of disruption that you're most focused on now?
So I pick a little bit up on what Janice said, because I think this is my view, is there's no such thing as a disruptive technology. There is disruptive application technology. So, you know, you pick things like smartphones. I mean, that tech has been around for a long time, and basically it took someone to put it together and think of a business proposition for changing it. And I think critically in defence, actually many of the technologies that we want to do to disrupt defence already exist. We actually just have to think more carefully and more thoroughly about how you change the structure of defence to be disruptive. Rethinking defence. Let's stop building 10,000-ton submarines and maybe build 1-ton submarines, and how do we get away with that, and what would it take to do it? You know, how we would actually go down the road and just buy our drones from JB Hi-Fi, and what would that mean? And that's happening because other people are thinking about that as well. And we talk, I'm on this project at the moment called Post, which is about, automatically detecting and counting post-truth. So, an awful lot of things are actually about the semantics of cyber, not cyber itself. And so you can disrupt defence in lots of really, really interesting ways, actually using technology that's already around. And I think the crucial thing is for defence to rethink the way it runs as a business, and that's disruption.
All right, we'll definitely come back to that as well. Brad, unfortunately, you're at the end of some quite complex and deep answers there. Is there anything left that sits in your mind?
Yeah, so I want to take us down a couple of notches and say that one of the most disruptive technologies, I think, that's about to really explode, if you pardon the pun, is something that's actually being developed more quickly outside of defence, but it'll soon have significant defence application, and that's batteries. It's the ability to generate power, store power, and transmit power effectively underpins just about everything that we talk about in technology. So I think battery. I think we can then link that with smart materials. Imagine a soldier going out there with a very tiny battery that's going to power up all these systems for a day. He generates the power and transmits it through a suit that's made of smart technology, smart materials. That's the sort of thing. But at the core of all of that is the battery power, and we see people like Tesla. What's his name? Elon Musk. His focus is battery power. His focus is how do you store that power in an efficient and effective way. So I bring it down a little bit, but I say that's a really disruptive technology. When you then say, well, what does that affect? It affects everything. Hugh said the technologies have been around for a long time. When I look at autonomy, the world is just waking up to autonomy. The world's still fairly scared of autonomy. But the world's waking up to autonomy, but actually those technologies have been around for, it's almost 2 decades we've been working on those technologies. Haven't changed much in those 2 decades. What has changed is the ability to implement them properly. And that leads on to another area where I think significant disruption is going to occur or be achieved, and that's in the area of data mining. And that's another area, interestingly, where defence is playing a minor role in that. We're going to be users of the technology, but data mining, banks are playing a huge part in that. There's all sorts of industry out there that is interested in data mining. And when you look at technologies, when you look at autonomy, when you look at technologies like that, it's all based on having the right information at the right time. And that's why data mining is so important.
Right. So clearly a lot of different areas there, all happening simultaneously right now, and I suppose as a country of 20-odd million people, we have to be somewhat careful about where we pick and choose to make our investment. How does a country like Australia then decide where to focus its effort and energy, given that there are so many different options out there?
I think Brad should start again on this.
I would say that wherever you can get the money to support it, that's where you start. But that's being a bit flippant. But I think, Steve in his opening introduction touched on an area that I think drives a lot of, or could drive a lot of Australian technology, and that is we have a huge, as far as defence goes, we have a huge area to protect, to secure. We have a small population. What comes with a small population is a small budget. So the smarter you can do things, the more effective it is. And autonomy is a really, really good area in that. Australia's always been at the forefront in autonomy, or unmanned systems, remote systems. One of the very first remote control aircraft that was ever used in the world was the Jindavic target drone, and that was developed just down the road in Fisherman's Bend here. We've got the NOLCA system that is an autonomous system, very smart autonomous system. One of the things that I'm very excited about, but also very frustrated about, is we hear a lot about what's going on with Google, what's going on with eBay, all the advances they're making in autonomy. Actually, when you dig into it, the engineers, the scientists that are developing that technology, a large number of them have come from the group that we developed in BA Systems, that Hugh developed, that DSTG developed, that they're not getting the work in Australia, they're going over and they're showing the world what Australians can do.
There is a narrative that exists in Australia. I know Hugh will probably want to comment on this, and it's come up several times with regard to recent innovation statements. It suggests that we are a clever country, that we are innovative, that we can invent things. We are not particularly good at taking those inventions and making money out of them. Firstly, is that true? Does it apply in defence? And if it is true and applies in defence technology, what do we need to do in order to change that narrative to one where we not only invent things, but make money out of them as well? Janice?
I'll give it a go. I think it's true to some extent. I think it's patchy. And why is it patchy is because we replace capability in fits and starts. So starting to develop a national shipbuilding plan is recognition, I think, that you cannot keep an industry sustained through fits and starts. You cannot keep an industry sustained only through sustainment, because the skill sets that you need for sustainment are different to the skill sets that you need for design. They inform each other, but they're not the same skills. I think that with this last defence white paper and having industry for the first time identified as a fundamental input to capability is recognition by the government that it's important that we actually have industry that's there to provide an assurance of supply for some critical areas. And I think that we have the prospect, we have a once in a more than a generation opportunity with this defence white paper and the funding associated with it to be able to demonstrate to government that their faith in doing that is well placed. So we need some wins so that we can show that we've got some innovation that has proven military utility in a comparatively short time from maybe things that we've had in the store cupboard, in order to be able to have them continue to invest with us in technology for the future. I think that it's really important that we work together on the science with the capability managers, the people who need capability and define what they think their requirements might be, and industry to transition something that has into military utility. But unless we all talk to each other really regularly and really openly, then we'll fail.
So I'm not quite as negative, I think, as you. I mean, as you know, I've had a big background in the mining sector, as a good example. You know, I look out there now, there's more autonomous vehicles working in the Pilbara than there is in California. It's just that we don't often realise the kinds of technology that's been going on self-driving trucks, unmanned trains, unmanned drills. You know, there's a room in Brisbane, they're operating not just the mines in the Pilbara, but all the ones in Mongolia and in Utah and so on from one room. And you look at the technology there, and people say mining isn't innovative. It's not technology. We're just digging holes in the ground. Not true at all. You know, I think that there is all this stuff going on, and what's changed in mining is really, if you like, the pressures of costs, the pressures of safety, the pressures of environment, and if you like, the need to be disruptive in some kind of way. And actually, I had to give a talk the other week to miners about why they weren't being innovative. But actually, it's kind of an odd thing, right? And so you can give the examples of the banks or whatever, but in the end, that whole industry has really, is being, digitally disrupted in lots of really interesting ways. So I come to defence. Defence is Australia has really unique challenges, and I think you're right about the autonomy part. I think that the biggest challenge, though, that we have is education. There's still this tendency in this country to go and want to buy platforms, and that's not just this country, I have to say, it's a lot of countries, right? Whereas actually what you should be buying is capabilities, and those capabilities need to be driven by an intelligent customer and an intelligent supplier that basically says, actually, part of that capability, we could use a robot to do it, or we could use AI to do it, or whatever. And you didn't ask for a robot or a piece of AI, but that will help you solve the problem. And that's kind of the way that commercial companies think of it. Nobody ever asked for a robot to change the Pilbara. They asked for a new way of doing business. And I think, we need to adopt a common thing in Australia to do that. And we also need to sort of start building a niche that says, actually, we have thousands and thousands of square kilometres of ocean and land and everything else, and therefore our capability needs to be wide areas of ocean surveillance or whatever else it may be. And that's the capability. And for that, robotics, AI, and all these other things are going to be part of that solution, and therefore we should get on and start developing them. So, again, it's kind of, you need to treat it a little bit more like a disruptive business in some sense.
To possibly stay on a negative tone then, you mentioned the question of cost. Oh, sorry, Andy, did you want to jump in on that?
I echo a lot of what we said. I think, when we actually talk about disruption in the UK, we don't necessarily always talk about technology. I think he was right. But so I think from a defence point of view, from a customer point of view, from the UK MOD, it's about it's about protecting yourself from being disrupted, and it's about having actually a military capability that can disrupt. I think from a company point of view, it's understanding the business models, that disruption, that capability that we produce. So it's not the technology. We don't produce the material. We embed the material actually on our aircraft, or we embed our material actually on our ships, submarines, or whatever it is. We need to understand the business model that imbues, and it may be a completely new type of system. And I think that's the importance. So autonomy, if you will, is transformative in terms of that system. Now, it's not really all that transformative. I mean, a Typhoon aircraft flies itself already. I mean, essentially, we moved from a Lancaster bomber as something actually having a crew complement between 9 and 7 to one guy flying a mission now. So the computers actually on board that aircraft are doing a tremendous amount. So I think we sometimes put ourselves down in terms of not being all that disruptive and innovative. We are, and I think we forget that. But the thing is, it's about the business models, it's about actually how that actually works, and actually understanding that capability that is really the actually sort of core piece. And I think that's the thing that we have to actually sort of think about. And really then, I think really from a UK point of view, and I think this probably goes across, is that a lot of that new capability is not just going to come from the defence arena. Yeah. It's going to come from outside. And it's going to come, and therefore, how do we actually sort of do that? Well, we do that through partnering with people, we do that through working with other people and bringing that in. And I think large industry has a role to play in that as much as actually small industry with those innovative ideas. That's not to say that we don't have the innovative ideas ourselves. So I think, if you will, this whole disruption piece, therefore, is quite multifaceted. It's about disruptive military capability, it's about the business models, it's about partnership, and I think also, to my mind, it's also about having the right skills in the right places so that you can be agile enough to really harness that and actually capitalise actually on that capability.
So I want to follow up. So, because I mean, you brought together 2 points that both Brad and you have, which is this issue that the reality these days, which was not true 30, 40 years ago, is 90, if not 99% of technology is no longer in defence. And so there has to be this kind of partnership that goes on with, what the Googles of this world are doing or whatever else is, because they're doing machine learning and deep learning and everything else. And I think that is disruptive. It's disruptive for your business and how defence needs to think in the future, because it's no longer, keeping all the technology secret, because actually all the technology's out there. And I mean, how are you going to ingest it? How are you going to use it? Because basically your competitors, both nationally and commercially, are already doing that.
Can I just give?
Please.
I'll just take
a seat. Yes.
I think just to
disrupt it out now.
I'm very conscious this was an Australian-based question, and I actually got a British answer. Just to give an example, so around some civil technology, there was a company actually in the UK. It's called Intelligent Textiles Limited, and it makes intelligent cloth. So why on earth actually a defence company interested in that? What it allows you to do is pass data and power through the cloth without the need of wires. And this basically a very small SME actually had this, and they couldn't get it to market. And so we've worked with them to get it to market in terms of driving down the price point. So we've brought our expertise in terms of building the business model, thinking about the intellectual property. We've taken that capability and put it into an old mill in Preston to manufacture it, which is so quite something, to the point where we've actually got something at a price point that makes sense. Now that then goes into body armour for a soldier, allows them to plug all their devices in, or actually someone actually sort of flying in a cockpit, or you can actually imagine other areas. So I think defence has a role, but if you will, the idea, if you will, that came from is it's an intelligent cloth, and who's to sort of say, that's going to come from elsewhere. So I think that's actually, if you will, an example where defence can actually play a significant role in that, because often we have the hard problems, but the technology comes from elsewhere.
So we've heard discussion of a number of these disruptive technologies, hypersonics, autonomous systems and AI. There are plenty of others out there. We're looking at next generation weapon systems that are in development at the moment. There's a range of technologies which are working to increase survivability. But this isn't the only market where this is being developed, and I don't think I've been to a country yet that doesn't consider it has smart people. So if we take smart people out of the equation, Brad, I'll throw this to you then. What gives you faith that we can actually participate and compete when it comes to the development and deployment of disruptive technologies in defence?
Because we're Australian? No, I've actually had the great experience of working on a number of big international programs. The first one I ever worked on, apart from NOLCA, which was essentially an Australian program with US funding, the next program I worked on was a NATO missile development program, Evolved Sea Sprayer missile. When we started on that, before we were British Aerospace, before we were BA Systems, we were AWA, Defence Industries. AWA, for those who don't realise and can't make the link, made TVs and fridges and that sort of stuff, and they also made barra buoys, and as a result of making barra buoys, which were metal tubes full of electronics, they were asked to take on the NOLCA contract, and so they got into defence in that way. So we were from AWA, a little Australian electronics company. We headed off to Tucson, Arizona, to the Hughes and now Raytheon Missile Systems Company. Huge company. You know, you look at every second missile that you see is a Raytheon missile, and we were 4 engineers. We were really excited. We were heading off, and we were going to learn a whole lot of stuff from the big guys. You know, we were going to learn so much. Probably within, I'll say, 2 days, we were having a beer, and the youngest of the 4 of us was the first to crack, basically, and he said, "I'm so disappointed." He said, "I've been in meetings and I'm teaching them. They're not teaching me, I'm teaching them." When we look at why that might be, Australia, as we said, small population, small budgets, we've got a big problem. No smaller problem than anyone else, we've just got less to deal with it. The model that drives in Australia in particular, and when you compare that to the US, it's very obvious that the model that it drives is that an engineer working in the defence industry in Australia isn't able to work on multiple different projects, one after the other, all in the same area. My colleague in the US on this missile program, when I spoke to him over lunch the first day, I said to him, how many missile programs have you worked on? And he said, "I've worked on 7. And I'm sitting there thinking, God, I've worked on 1. You know, I'm just going to have to keep quiet.
You got yours right first time. You had to do 6 others.
Yeah, that's right. But the fact is, he worked on the actuator design for the tail fins of 7 different missiles. I'd worked on NOLCA, and I'd worked on just about every element of NOLCA, from the technology design through to the production, through to the in-service support. And what I'm getting at is we get a broad exposure, we get broad experience, and that allows us to think a lot more laterally. We understand the whole system aspect, and it allows us to apply a systems thinking. And to me, in the small number of examples I've had, that has put us right up the top. We're equal. And we used to have a saying in that program that if there was 100 US missile designers and 100 Australian missile designers, we'd know about the same. If there was 2 US missile designers and 2 Australian missile designers, Australia would be able to design the whole missile, whereas the US would be able to design one component. And I think that's what puts us in a good place.
I agree. I think it's like David and Goliath. And I think another advantage in being small and when it comes to disruption is that we do have that exposure to other disciplines, other capabilities, but really importantly, we have a lot of exposure to the military. We embed scientists, embed scientists in industry, but also with the military, so you understand what the needs are, understand their language, and you can translate it in ways and take it from area to area. Whereas countries that are much wealthier and have a business model that's highly specialised and narrow, they don't have the same agility. So I think we're in a really good position to be able to take advantage of building across the interfaces and creating our own disruption and niche areas where perhaps they have yet to be identified. I think that that's really important. I think that being able to bring students in so that they have the exposure in ways and to see what happens down the track and live that close experience, I think is how we attract them for the future and away from cranking a handle in a bank. Once they've bought a house. So they don't need that much money anymore.
So I'll go to the audience in a moment. So if anyone's got a question brewing, I'll give you the opportunity shortly. And as I said, I'll pick a volunteer if I don't get a hand up. Before we do that though, how do we take what you've just said then, Janice? How do we accelerate that process? Or how do we make sure that we don't lose some good ideas along the way? Because we do hear stories of Australian defence technology, which in some cases has to be sold overseas before it can be bought locally. You heard Andy talk about the evolution of the manufacturing sector. Now, we've lost a lot of our manufacturing capability in recent years and will possibly struggle to get that back. What changes would you like to see made today to ensure that those innovative ideas that are being generated by your young scientists can actually get into the hands of people within the Australian defence sector?
One of the things that we're trying to do, using the Next Generation Technologies Fund, because that's an opportunity for us, it's new money, is trying to open up opportunities where we both educate small industries on defence and defence context, to invite, we've just put out in the last couple of days to the universities, 30-odd universities in Australia, making calls in a series of technology areas, saying here's areas where we think there might be technology of interest to defence. Give us an idea of what you would like to do in this area in research.
What's that program called, Janice?
It's the SERA program, Competitive Evaluation Research Agreement. And so we will assess that, we will give out grants for people to start to understand and raise their awareness of defence and defence's needs. In the last couple of years, we've had what we call Partnerships Week, where we have our scientists talk to industry people about some of the technologies that we're involved with that might be ready to be transitioned or might need a partner early on. But this year we're doing something different. We're going to invite other people and come and make pitches for us so that we can then give them money to undertake the research, so to build the collaboration. So we're determined not to have it live in a cloister, to try and build that awareness, to build the understanding that you can get a career in science or in engineering inside Australia.
So really, I think this is really quite an important point. So you don't get disruptive technology unless you actually sort of give it air. You have to actually sort of do that by not actually sort of seeing technology from a technology point of view. You need to sort of see as to how it fits, and you need to think actually about the business model around that, and that business model needs to be flexible as you actually move that forward. And I think that's a really quite important piece.
I just want to add something slightly different to that, and that is that we're in an industry that takes a long time to develop anything. We're hearing that the greatest technology ever to fly has landed in Australia this week, and it's going to be at the air show. But I can remember back 20 years ago working on stuff to do with Joint Strike Fighter. It takes a long time to mature anything. To try and put a traditional business case mentality on top of value propositions for disruptive technologies is approaching it the wrong way. What we really need to think about is what are we doing today that can help us fund disruptive technologies that will then allow us to invest in 10, 20 years' time into the next lot of disruptive technologies. And just to finish it with a question is, if 15, 20 years ago we had have realised that, as Brad said earlier, our manufacturing industry is just about dead and we probably won't be able to resurrect it. If we had have known that was the impact of decisions we were making on where we invested our money, would we have changed our mind on that? And what I'm really saying is we need a big picture approach. We need to think long term, and we need to do that as an Australian enterprise, where the enterprise is government, defence, industry, academia.